Hi guys, and welcome back to class. This is Unit 1, Day 5, and we are writing explicit functions. So our objective today is that you will write an explicit function for an arithmetic sequence. Given a sequence, students will be able to write an explicit function from the first term of an arithmetic sequence. So the first thing we're going to do is just recall what a recursive function was. So remember, a recursive function built from the previous term. So when we wrote the function, and if it said function, then we used f of n is equal to f of n minus 1. And then we figured out what our d value was. So for here, we are minusing 8 to get from term to term. It's important to note that you could multiply it by 2. However, 16 times 2 does not give you negative 24. So that is not multiplying by 2. But minusing 8 works every time, so that is our common difference. And then remember, we would always state the first term, so f of 1 is equal to negative 8. So now you guys do number 2 and write the recursive function for number 2. You should have gotten that f of n is equal to f of n minus 1 plus 5, because our numbers here are getting bigger every time, and they're getting bigger by 5. Also, remember that anytime you have a list, this is term number 1, so you put 1 and negative 25. Going backwards from that, if we are given the recursive function and we want to write the first 5 terms, we see that the first term here should be 9, so we write 9, and then we see that we are adding 6. Because remember, this says the next term is the previous term plus 6. The first term is 9. So the next term here would then be 9 plus 6, which is 15, plus 6 is 21, plus 6 is 27, plus 6 is 33, and that is that one. You guys try number 4. For number 4, they told you the next term is the previous term minus 4, with the first term being 3. So your sequence should have been 3, negative 1, negative 4, negative 7, and negative 10. So recursive functions always find the next term using the previous term, which can make it difficult to find a far-off term like the 100th term. So if you remember back to last week, we looked at this sequence here, where at the beginning we had 1 dot, after 1 minute we had 5, and after 2 minutes we had 9. So now we want to think about how can we find the 100th term. So let's look at this in a table. So I've gone ahead and filled in the table for you with the pieces of information that we knew. We found last week that at 3 minutes we'd have 13 dots, at 5 minutes we'd have 21 dots, and at 12 minutes we'd have 49 dots. So let's look at how this is changing in our table. So to get from 1 to 5, we added 4. So 5 was 1 plus 4. Then to get to 9, we added 4 to 5. So we had 1 plus 4 plus 4. And then to get to 13, we added 4 to 9. So that's 1 plus 4 plus 4 plus 4. So really in the how it's changing, we're writing it recursively. So you write it in terms of the one above it. So you might remember that 4 would then be 17 because it would be 1 plus 4 plus 4 plus 4 plus 4. And we're just expanding out the number of 4. So we're adding what was there before and then adding an extra 4 to the end. So now let's see if we can simplify this down a little bit and see what it looks like. So I can see in all of my rows, I start with 1. So in my simplified form, I'm going to start with 1. And then in all of them, I add some number of 4s. So I'm going to add 4. Well, I added 4 once here. So that's just 4 times 1. I added 4 twice here, so I'm going to have 1 plus 4 times 2. And then here I added it 3 times, so I'm going to do 1 plus 4 times 3. Here I added it 4 times, so I'm going to do 1 plus 4 times 4. And here I did it 5 times, so I'm going to do 1 plus 4 times 5. So now I'm seeing a couple of constants in here. I'm seeing the 1 that I've added each time. And then I'm also seeing the 4. And the 4 makes sense because the 4 is the common difference. That's what I'm adding every time. Then I have this number here. And I want to think to myself, where can I get that number from? Where do those numbers come from? They have to mean something. And if you notice, these numbers are the same as these numbers. The number I'm multiplying by is the same as the number of minutes for that term. So if I wanted to find the 12th term, I already know it's 49. But let's see if I can write an expression here to match. So to match what I did above, I would start with 1. I'm going to add 4. And I noticed that the number in the parentheses was the same as the number here. So I'm going to multiply it by 12. Putting that into my calculator, I get 1 plus 48, which is 49. So I can write my expression in terms of n as 1 plus 4 times whatever n is, which happens to be, remember, the term number. So if I want to find the 100th term, then I'm going to do 1 plus 4 times 100 to be 1 plus 400, which is 401. If you remember in our discussion in class, we talked about the fact that there was one dot in the middle that was added each time. And a lot of you saw it growing with the 4, and then we had the 4, and then we had another 4. So that's 2 groups of 4 plus the 1 in between. 2 groups of 4 plus the 1 in between. Now let's look at this example. So let's do this one here. Each block is going to represent a push-up on that day. How many push-ups will be done on day 20? So we found day 1, there were 3 push-ups. Day 2, there were 5. Day 3, there were 7. And day 4, there were 9. So we found pretty quickly that we were adding 2 push-ups each time. But now instead of starting at 0, we're starting at 1. We're starting on day 1. So we need to write this out. So you always take 3 and you're going to add 2 to get 5. So 5 is just 3 plus 2. And then 7 is 3 plus 2 plus 2. And then 9 is 3 plus 2 plus 2 plus 2. I'm just going to fill in a 5 just to give us an extra 1, which would be 11. So 3 plus 2 plus 2 plus 2 plus 2 more. I don't want to have to write out all of the 2's to find 20 and do 6, 7, 8, 9, 10, all of those. That'd be a lot of work. So we're just going to try and figure this out. So when I write it into simplified form, I see that 3 plus 2 is 1. I see that they all have 3. So it has to start with 3. Then they all add 2 some number of times. This one's twice. 3 plus 2 times 3. That's 3 times. 3 plus 2 times 4. So that's 4 times. This was only 1 time. So 3 times plus 2 times 1. But now I'm seeing that my numbers here are not the same as my numbers here. They're 1 off. The term in the number in the parentheses refers to the previous term. So if we think about it, you could think of this in two ways. You can think of this as saying 3 plus 2 times the term number minus 1. So 2 minus 1 is 1. 3 minus 2, I'm sorry, yeah, 3 minus 1 gives us 2. 4 minus 1 gives us our 3. So if you think to when we talked about recursives at the very beginning, when I read this to you, I said the next term is the previous term. N minus 1 helps us to see the previous term. So this is our n value. So to find the nth term, we're going to take 3 and add 2 n minus 1 times, because this number is 1 less than this number for all of my rows. So to find the 20th term, I'm going to plug 20 in for n. So that'll be 3 plus 2 times 20 minus 1, which is 3 plus 2 times 19. And that would give us 41. So there's 41 push-ups on day 20. What we've written is an explicit function. And all an explicit function is a function that defines any term in a sequence. It will either state the 0 term or a term with the corresponding term number and the change. So for our example I've been using with the recursive, we wrote the recursive function here. The explicit function is just saying the next term is this term 8 plus 2 times n minus 1. So that's really times the previous term number. This is the unsimplified version. The simplified version, so this here gives us that the first term is 8. In this one, it's 6 plus 2n. So it's telling me the 0 term is 6. This form, this 8 plus 2 times n minus 1 is the form that gives you the term with the term number, while the other form is the form that gives you the 0 term. So when we compare recursive versus explicit, we want to know when we use which. There's two different forms. How do I know which is best? If you're only finding the next term or maybe the next 2 or 3 terms, then the recursive function is best. That form uses the previous terms. You just need to add it and you're going to find it very quickly with very little math. However, if you're trying to find a term that's far off from the terms that you have, then you're going to want to use the explicit function, because then you can just plug your term number in and get out the term. So use the given information to decide if you should use the recursive function or the explicit function to find the given term. Then find the term. So here they give you the explicit function and the recursive function. So they've given you term 1, 2, 3, and they're looking for 4. 4 is what we don't know. Since 4 is the next term in my sequence, I want to use the recursive expression because I'm finding the next term. To find the 4th term, I'm just going to do 2 plus 8. I'm just going to do 2 minus 3 to get to -1. I know this because I looked at my common difference I looked at my common difference up here in my recursive formula. Looking at number 2, they have once again given me the explicit function and the recursive. So remember that explicit says that the next term is 8 minus 3 times n minus 1. The recursive says the next term is the previous term minus 3 with the first term of 8. Now I'm looking for the 50th term. Since I'm looking for the 50th term, if I go from the second term, I'm going to have to find terms 3, 4, 5, 6, 7, 8, 9, 10, all the way to 50 in order to find the 50th term. That's going to take a really long time. So instead, I'm going to use the explicit function because I'm finding a far off point. Then I'm just going to plug 50 in for n to the explicit equation. I'm going to do 8 minus 3 times 50 minus 1, which would be 8 minus 3 times 49, which will give me negative 139. Now, could you use the recursive function and find the 50th term? Yes, but you might be here for a while. Could you, in number 1, use the explicit function to find the 4th term? Yes, but it's going to take a little more math. So that's why we have different functions to help us with different needs. You guys try and do numbers 3 and 4 and then come back to check your work. So as you can see in number 3, since you were finding the 20th term starting at the 8th term, then you'll use the explicit. The thing to make sure is that you note is that now they've changed it to an 8 instead of a 1 because they gave you the 8th term. So you would plug in and do 56 plus 14 times 20 minus 8 and get 224. In number 4, the value of the 8th term is 56. The sequence is increasing by 14 at each step, so you'll find, then they ask you to find the 9th term. So you'll use the recursive because that's the next term in the sequence, and the 9th term will be 70 because you will do 56 plus 14. So to write an explicit function in function notation, you will first find the common difference, decide which term you're using and what term number it is, and then fill it into this here equation. This will be the term that you're using. This will be the term number. And then obviously D is your common difference. Adjust your sign if necessary if you are subtracting instead of adding. In class, we will do the rest of the examples on this worksheet so that you can get a better understanding of how to write an explicit function.